Okay, now you finished the second question. Let's go over it together. We need to compute the regression, the correlation coefficient. We need to know the covariance, the standard deviation for x, and the standard deviation of y. The covariance is 7.5. Standard deviation of x is the square root of 2.5. It is 1.58. Now let's compute the standard deviation of y. So we square each deviation score. We will have 36, 81, 9, 0, 0. We add them together. Sum of the squares for y is 126. We divide 126 by n minus 1. We will have the variance of y, which is 31.5. The square root of 31.5 is deviation of y, which is 5.61. R equals to 7.5 divided by 1.58 multiply 5.61, which is 0.85. Then we learned that the regression coefficient equals to the correlation coefficient multiply the ratio of standard deviation of y and the standard deviation of x. We plug in the number, so b equals to 0.85 multiply 5.61 divided by 1.58, which is 3.01. From question 1, we got the b weight, which was 3.00, so these are very close to each other. The relationship between the regression coefficient and the correlation coefficient is that b equals to r multiply the ratio of sy and sx. Now you can work on the question 3, which I already figured out. So you can kind of work on this on your own quickly. Based on this formula, if the standard deviation of y equals to the standard deviation of x, then the regression coefficient will be the same as the correlation coefficient. B would equal to r. Under what condition sy equals to sx? For any two distributions, one will sy equals to sx. The shape of the x distribution equals to the shape of the y distribution. Can we transform the x and the y distribution into a standardized distribution? Therefore, they would have the same standard deviation. Yes, we could transform x and y distributions into z distributions. That is, if we transform all y's into z-scores, y distribution becomes a z distribution. If we transform all x into z-scores, the x distribution becomes a z distribution. Then for a zx distribution, the mean is 0, standard deviation is 1. For zy distribution, the mean is 0, standard deviation is 1. Then if we transform two raw distributions into the z distributions, sx will equal to sy. That is zx, then the mean of x and the mean of the z distribution of x and the mean of the z distribution of y would also be equal. They are both 0. Standard deviation of x and standard deviation of y would be 1. Okay. Therefore, when we transform x and y into z distributions, the unstandardized regression coefficient, the b value or b weight, is called a standardized regression coefficient, and we use beta to present the standardized regression coefficient. And beta equals to r multiply summation of y divided by summation of x. Both are 1s, so beta in numerical values, it equals to r. The formula is that zy hat, the predicted z-scores for y, equals to beta multiply the z-score of an x plus a. So that is the regression equation for the standardized distributions of x and the standardized distribution of y. Now we know b, or regression coefficient, becomes beta, standardized regression coefficient. What is the intercept or standardized intercept? What is the formula for intercept? Intercept equals to the mean of y minus beta multiply the mean of x. For z distributions, the mean of y is 0 and the mean of x is also 0. So for the standardized distributions, intercept is 0. Therefore, the standardized regression formula equation is very simple. It is predicted z-score of y equals to beta multiply z-score of x. To just make things simple, so to simplify the formula, we will just write as y hat equals to beta x. And when you see beta, you know that these formulas are based on the z distributions. Y hat would be the predicted z-score of y, and x would be the z-score of x. Okay, now you can continue in class question number 4. In your own words, explain what beta is. Then for this question, compute beta. You can pause my lecture and work on this question. After you finish your writing, you can continue my lecture. Beta equals to r, which is 0.85. The last question is, what is the standardized regression equation? If beta is 85, then the standardized regression equation is y hat equals to 0.85 multiply x. Let's review this section. We explained or reviewed what R is, correlation coefficient, what B is, regression coefficient. What is the relationship between R and B? B equals to R multiply the ratio of standard deviation of Y and the standard deviation of X. Finally, we introduced the beta, the standardized regression coefficient weight, and beta equals to R. Finally, I want to remind you that what is the similarities and the difference of correlation and regression? They both, in fact, describe a relationship between variable x and variable y. For correlation, it only describes how one variable change along with another variable. So x change, y change, or y change, x change. It does not matter which variable goes on the x-axis or the y-axis. Here is the relationship between parents' IQ and children's IQ. The correlation is 0.50. You can put the parents' IQ on the x-axis or you can put the parent's IQ on the y-axis. It does not matter. It does just mean they change together. That's correlation. On the other hand, the purpose of regression is different. For regression, we want to predict y from x. We want to predict y from x. So x is also called a predictor or independent variable. It must be on x-axis. Predictor must be on x-axis. And y is called the dependent variable with the criteria. It must go on the y-axis. With this regression line or regression equation, we want to predict children's IQ with a parent IQ. We want to know the y-hat. That's the purpose of the regression. To summarize, today we learned what the best fitting line is, what the rationale of choosing this best fitting line. Second, we learned how to compute the regression equation, how to compute the intercept and the scope. Third, we learned how to use the regression equation to predict a y. Then we focused a lot of attention on the relationships among R, B, and beta. What is the relationship between R and B? What is beta? Why is beta equal to R? Finally, we explained the similarities and the differences between regression and correlation. That's everything for the lecture. So you should finish the whole in-class exercise. I will collect this in-class exercise next Tuesday. Then you will need to work on the lab worksheets as well as the homework assignments. The TAs will collect lab worksheets and homework assignments during the lab section next week. Okay, thank you. Have a good week. Bye.